carbon capture, nature, and how it applied chemical engineering. So the content include the natural on carbon capture, the underlying principles and how it's applied scientifically, the relevance of carbon capture and how this helps engineers further progress the development of mankind.
While carbon cycle describes how carbon moves within the environment, carbon capture aims at reducing CO2 emissions into the atmosphere, hence reducing greenhouse effect. Nature has done this for a long time through photosynthesis, where plants and aquatic plants use sun and CO2 to form organic compounds. CO2 reacts with minerals to form carbonates and rocks in geology, while water bodies holds CO2 as a dissolved substance.
Now moving on to the underlying principles. Carbon capture and storage is based on separating carbon dioxide from industrial exhaust gases before it's released into the atmosphere. The process relies on chemical and physical science, specifically how carbon dioxide behaves differently from other gases, allowing it to be selectively captured, compressed, and stored underground. There are three main capture routes: pre-combustion, post-combustion, and oxy-fuel combustion. Post-combustion is the most widely used, as it operates after fuel has already been burned and can be fitted to existing power plants without major redesign. A key method here is chemical absorption, where carbon dioxide is dissolved into an alkaline solvent, most commonly organic amines like MEA, through a reversible chemical reaction. The carbon dioxide-rich solvent is then heated to release pure carbon dioxide and regenerate the solvent.
Carbon capture technology has been created as a result of fossil fuels burning, which causes climate change. This affects the health of the planet, for example, kerosene being burned in aeroplanes. Carbon capture and storage is the most common process in carbon capture. It's super efficient and reliable. The process involves amines as a solvent, which collects the carbon dioxide, is reheated and separated. This is transported down pipes. Shell has a station in Canada that does this. Carbon capture allows companies to plan for net zero. Globally around the world, there is a capacity of 50 megatons of carbon to be captured, and approximately the same amount of carbon is being captured. This process is therefore very efficient. Carbon dioxide is a massive contributor to global warming as it acts like a blanket around the Earth. UCL have linked global warming to 1 in every 5 deaths. This is because famines, harsh weather, and heat-related deaths have become more common. Carbon capture is therefore an amazing technology for chemical engineers, as it both helps reduce waste and save lives around the planet. Other processes include direct air capture, which uses fans to pull in air from the atmosphere. This then is separated, with the CO2 becoming liquid and can be used in things such as refrigeration. Thank you for listening.